All right, so now we're going to multiply radicals. We've already simplified radicals, right? And it's just making sure we had the prime factors down. We then added and subtracted radicals. We can't add or subtract unless we have like terms. Now we're going to multiply radicals. And there's this major theme here. You can multiply radicals, but if I had like the square root of something, let's call it A, and I multiply that by the square root of something else, let's call it B, then that is the same as me taking the square root of the product of those two things. All right. So for example, if I said the square root of 3 times the square root of 2, I would get the square root of 3 times 2, or in other words, the square root of 6. Now I need to make sure that this cannot be simplified. Since I already have it written out right here, I see that those are both prime. I cannot simplify it. We're good. All right. What if I did something like the square root of 90? All right. Actually, you know what? Let me not do that. Let me erase that. What if I did one like here on Alex? The square root of 6 times the square root of 12. Well, that's really the square root of 6 times 12, or 72, which can be rewritten when I take the prime factors of 72. I get 8 times 9, or 2 times 2 times 2, that's 8. And then 9 is 3 times 3. So if I write that as 2 times 2 times 2 times 3 times 3, all I really did was take the prime factorization of 72. And then I'm looking for pairs, as always. So I can pull out a 2 and a 3. Remember, these are factors, so I'm multiplying them all. And then on the inside, I have a 2 still, which is really just 2 times 3, or I can just do that math right now. 2 times 3, which is 6 on the outside, and the square root of 2. All right, so this is 6 square roots of 2. 6 square roots of 2. All right, now we could have done that a different way as well. Like if I looked at, or the square root of 6 times the square root of 12, I could just see this as square root, you know what? I could just go ahead and multiply it out, sorry. Thought I could do something even faster, but couldn't this be 6 times 12, which I could rewrite as 6 times, and then 12 is 6 times 2, right? Because that's 12, that's 6. Well, if it's a square root, I have a pair right here. That pair comes out, and I still have the 2. Either way, the idea of multiplying them together means you do it all under 1, like here or here, helps me to simplify those things. All right, I think that's all we really need to do. Just I can change the numbers. I can put some variables in there. In fact, let me see if I can find one with some variables really quickly just to make sure we're good. And let's do, for example, what if I did 10v cubed, take the square root of that, multiply that by the square root of 2v cubed. Well, when I multiply them together, I get 10 times 2. I'm just going to leave it written out. And then times v3, v3. So all I did was use that property to put all these under 1. Right? So if I do that, 10 can be written as 2 times 5. And then I bring down the 2. And then this, I'm going to, for right now, leave the same because I see they are the same. Because I'm looking for pairs, I can bring out a 2 and then a v cubed. And what I have left is just this 5. So that is the answer. Even though I have variables, it's the same thing. Now, I guess I could have just done the v's out. 1, 2, 3. 1, 2, 3, like right here. And then the 5 times 2, and then the times 2. And I would still end up with the same thing. 3 v's, 1, 2, and a 5 still underneath. Same idea.